In this video, I'm going to be going over Indices 1. This section will just show you how to use the simple laws of indices. So let's get started. Now the first thing is, what exactly is indices or an index? So if I have, for example, 6 times 6 times 6 times 6, I can group this all up into 6 to the power of 4. This basically just means this. Now, if I have 6 to the power of 4, this 6 is known as my base, and this 4 is known as my index, or some people call it the power. So, if I have something like 2 to the power of 2, that just means 2 times 2, which is 4. Now the first thing we're going to be going over is multiplying indices together. So, the rule for multiplying indices is, if I have a to the power of m times a to the power of n, that just gives me a to the power of m plus n. So, what this basically means is, let's go back to our 6 to the power 4 example, and multiply it by another 6 to the power of 4. When we're multiplying indices together, my answer is just 6, and then these 4 added up together. So 6 to the power of 4 plus 4, therefore 6 to the power of 8. Now we can actually prove this. So if I have 2 to the power of 3 times 2, I can turn this 2 to the power of 3, so 2 times 2 is 4, 4 times 2 is 8, so this turns into 8 times. 2 alone means 2 to the power of 1, so if you see something without an indices, just automatically assume that it is to the power of 1. So 8 times 2 is going to give me 16. Now, if we do it the indices way, 2 to the power of 3 times 2 to the power of 1, you know what we do. We add the indices together, and then we keep the base, so it's just 2 to the power of 4. And 2 times 2 is 4, times 2 is 8, and then times 2 again is 16. So, therefore, we proved how multiplying indices works. Now the second thing we're going to be going over is dividing indices. Dividing indices is also pretty simple. It's basically the exact opposite of multiplying them. So the rule is, if I have a to the power of m divided by a to the power of n, that just gives me a to the power of n minus n. So for multiplying, what we would do is we would add them. But for dividing, it's the exact opposite. Instead of adding the indexes, all we do is subtract them. Now, an important thing to note when you're multiplying or dividing, a lot of people tend to multiply the bases together. So what I mean by this is, if I have 2 to the power of 1 times 2 to the power of 3, a lot of people just say, oh, 2 times 2 is 4, and then 1 plus 3 is 4. This is completely wrong. An important thing to note is, when you're dividing or multiplying indices, is the base is always kept the same, whether that is an actual number or whether it's a variable such as x. So if I have, for example, for dividing 8 to the power of 5 divided by 8 to the power of 4, that just gives me 5 minus 4, which just gives me 8 to the power of 1, which is just 8 really. You can just write it as 8. If I have q to the power of 6 divided by q to the power of 8, we just do 6 minus 8, so that is going to give me q to the power of minus 2. And yeah, that's all for dividing indices. Now the last thing we're going to do before we move on to questions and into the more extended stuff is raising to a power. So what does this mean? So basically the rule is if I have a to the power of n closed in brackets and then I have an n over here, that just means a to the power of mn. So I'll give a quick example. If I have b to the power of 3 closed in brackets, the most important part that it has to be closed in brackets. And then this b to the power of 3 in brackets is to the power of 2. What this means is all we need to do is this 3 and this 2 is multiply them. So that just gives me b to the power of 3 times 2, which is b to the power of 6. That is how raising to the power works. And remember, the base and the index have to be closed in brackets. Okay, so now it's your turn. Have a go at these 3 questions. If you want to answer them, feel free to pause the video because I will answer the questions right now. So let's just remove these question marks. For question number 1, I have 2a to the power of 2 times 3a. Now in algebra, obviously, if you see a times, then you just times these together. So 2 times 3 is 6. And then a to the power of 2 times a. So again, if we just see an a like this, we automatically assume that it's a to the power of 1. And when we're multiplying indices, we have to add the indexes together. So it's just going to be 6a to the power of 2 plus 1, which is 6a to the power of 3. Now you might be confused because I just said that the base is always the same, and over here I did 2 times 3. So the base is a, and I did not change a. What I did change is the 2 and the 3. So if you're confused about that, that's what I mean. In algebra, if we have 2a times 3a, it's just 2 times 3, which is 6, and then a times a, which is a squared, because it's a to the power of 1 times a to the power of 1. So let's move on to the second question. I have x to the power of 3 times x to the power of 6 over x to the power of 5. So let's start with the top side first. X to the power of 3 times x to the power of 6 is just x to the power of 3 plus 6, which is just equal to x to the power of 9. And then I have it divided by x to the power of 5. So again, same thing here, nothing too hard. We just subtract the the powers together. So that is just going to give me x to the power of 9 minus 5. So that is just going to give me x to the power of 4. And now for the third one. So I have b to the power of 5 divided by b to the power of 3 in brackets to the power of 4. Now the common mistake people would do is first they do b to the power of 3 then to the power of 4. That is actually wrong. You need to do what is inside the brackets first. Remember, it's all about order of operations. BODMAS, PEMDAS, however you do it, you have to do what's inside the brackets first. So the first thing we have to do is b to the power of 5 divided by b to the power of 3. So that is just going to give me, when we've established that when we divide, we subtract the powers. So that's just going to give me b to the power of 5 minus 3 to the power of 4. And that b to the power of 5 minus 3 is just going to give me b to the power of 2. And then here is where raising to a power goes into place. When I have over here in brackets a base and a power, and next to it is another power, all we have to do is multiply them together. So that is just going to give me b to the power of 2 times 4, which is just going to give me b to the power of 8. And these are my final answers for these 3 questions. And yeah, we've officially finished how to multiply, divide, and raise to a power of bases and indices. Now let's move on to slightly more complicated stuff. Now when I was showing an example for dividing indices, you may have noticed that I had a negative power, which was q to the power of minus 2. I can simplify a negative power even further. So the rule for the negative powers is that a to the power of minus m is just going to be equal to 1 over a to the power of m. So if I have 2 to the power of minus 2, when we see a minus on a power, the first thing you immediately do is make it a fraction where the base is at the bottom over here. So again, if I have 5 to the power of minus 2, the second you see a negative number as an index or a power, you put the base over 1. But we're not done yet. So after you put the base as a fraction where it's a denominator, and there's 1 as the numerator, this 2 turns from a minus 2 to a positive 2. And then we just chuck it back in here. So 2 to the power of 2. So I have 1 over 2 to the power of 2, and I can expand 2 to the power of 2 to give me 1 over 2 times 2, so 1 over 4. So let me do another example, such as 4 to the power of minus 2. So the first thing is, the second you see a negative power, you turn it into a fraction where 1 is the denominator and that the base is the numerator. And then after that, this minus 2 turns into a positive 2, so it goes over here and becomes 4 to the power of 2. And then I can expand this for 1 times 4 times 4, and therefore it just turns into 1 over 16. And that is how we can expand negative powers even further. Now the final thing we're going to learn in this video is zero powers. So we know that if I have just a 2 over here, that just means 2 to the power of 1, which is 2. So what if I have something like 2 to the power of 0? What is that going to be equal to? Now, zero powers is the easiest thing. It is so easy. It's extremely hard to get wrong. So the last rule we're going to do is just simply a to the power of 0 is equal to 1. That's it. So any number you could possibly think of raised to the power of 0 is always equal to 1. So I can have minus 200 to the power of 0, that's just equal to 1. I can have 1 billion, let's just put a trillion zeros to the power of 0, that is equal to 1. Now, if you want to know why there are other YouTube videos, I can explain right now, but it's just way too much explaining. And yeah, now we've officially covered Indices 1, and let's just now go over some questions. Okay, so have a go at these 4 questions. If you're going to answer them, feel free to pause the video, because I will answer them right now. So question number 1, 5 to the power of minus 2. Again, for the negative powers, the second you see a negative number, you immediately make it a fraction where the base is the denominator and 1 is the numerator. And then the minus 2 turns into positive and is just chucked down at 5 again. So it's just 1 over 5 squared. So 1 over 5 times 5. Therefore, my final answer is 1 over 25. For question number 2, and I hope that was the easiest question you guys had to go through, just simply 1. I cannot explain it any further. Just any number, anything, x, y, b, anything to the power of 0 is just 1. That's it. Like, I cannot explain it any further. For question number 3, we have a x to the power of minus 2 in brackets and then to the power of 3. So this is an example of raising to the power, and we've established that we just multiply the powers together. So it's x to the power of minus 6. Now you can expand this even further by just going over 1 over x to the power of 6, where it's a minus number, so it turns into 1 over the base, and the 6 turns positive, so it's just 1 over x to the power of 6 to expand even further. Now for the last question, I admit it is really hard. So for the last question, the first thing we can do is that we can see that this minus 3 is negative, obviously, so immediately just make it a fraction. Don't try to do, oh, what is 5 to the power of minus 3 and then x to the power of minus 3. That's going to take up so much time, and you might need a calculator for all this. So just put it over a fraction immediately. No matter where the power is. If there's a negative, just put it over a fraction. So this turns into 5x to the power of 2. No, wait, sorry. 5x to the power of 2. And then this 3 turns positive, so it goes here as a positive 3. So I have 1 over 5x to the power of 2 to the power of 3, and I can now start expanding. So the first thing I can do is 5 to the power of 3. 5 to the power of 3 is 125, because it's 5 times 5 is 25, and then 25 times 5 is 125. And then x to the power of 2 times raised to the power of x to the power of 3, because it's in brackets, we multiply the powers, so it's just x to the power of 6, and that is my final answer. 1 over 125 x to the power of 6. And yeah, we've officially finished Indices 1. In the next video, I'll post Indices 2, where we'll move on into even more complicated stuff about indices. I hope you guys understood this video, and have a good day. Goodbye.